Chapter 2, Section 7 is on the graphical analysis of velocity and acceleration. And the way you would find velocity and acceleration in a graph is by finding the slope. And when you find slope, you do the change in y over the change of x, and that slightly varies for velocity and acceleration. For velocity, you do the change of displacement represents the y, and the change of time represents the x. And for average acceleration, the change in velocity represents the y, and the change of time represents the x. Now, a problem you would see is a snowmobile moves according to the velocity time graph shown in the drawing. What is a snowmobile's average acceleration during each of the segments A, B, and C? So the equation you'd use is average acceleration equals the change in velocity over the change in time. A equals positive 40 over 20, which gives you positive 2 meters per second squared. Segment B equals 0 because it's not moving up or down, it's staying constant over a period of time, which is guesstimated to around 27 seconds since it's not an exact one here, which still gives you 0 meters per second squared. And then segment C gives you a positive 40 meters per second over around 12 seconds, which gives you 3.33 meters per second squared. Another problem is a person who walks for exercise produces the position time graph given with this problem. Without doing any calculations, decide which segments of the graph, A, B, C, or D, indicate positive, negative, and zero average velocities. So as you can see indicated in the graph, A and C are both going to be positive because they're both moving upwards. B is going to be negative because it's moving downwards, and D is going to be 0 because it's not moving up or down, it's just going over, it's just constant. Now for part B, calculate the average velocity for each segment to verify your answers to part A. So you use the equation velocity equals the change of displacement over the change in time. Now A is a positive 1.25 kilometers over a 0.2 hour period, which gives you positive 6.25 kilometers per hour. B is negative 0.75 over 0.2, which gives you negative 3.75 kilometers per hour. C is a positive 0.25 over 0.4, which gives you positive 0.625 kilometers per hour. And D is 0 over 0.2, which gives you 0 kilometers per hour because it's constant. It's just moving over a period of time, but not changing its distance. Now, for the last question, it says a bus makes a trip according to the position time graph shown in the drawing. What is the average velocity, magnitude, and direction, which is the direction is going to be based on the positive and negatives that you give before your number, which is going to be the magnitude of the bus during each of the segments A, B, and C. So you're going to use velocity equals the change in displacement over the change in time. And A is going down 30, so it's negative 30 kilometers over 1.5 hours, which gives you negative 20 kilometers per hour. The negative shows the direction of it moving downwards. The 20 is your magnitude, your number. Now for B, it's positive 10 over 1 hour, which gives you positive 10 kilometers per hour. And C is positive 20 kilometers over 0.5 hours, which gives you positive 40 kilometers per hour.